Unite beyond boundaries. Innovate together. Joe's PANKRATION 2024. No border.
Go ahead.
Hey everyone. Today I'll be talking about architecting serverless applications with data streams and pipes. I'm Zachariah Noel. I'm a senior developer advocate at Freshworks. I'm also AWS Serverless Hero. I'm part of AWS user group Bengaluru in India. And I come from a background of being a serverless architect, and I talk a lot about serverless on my newsletter and blog called the Serverless Terminal, and also co-run a broadcast called the Zach Show Talking AWS. So over to the session about event-driven architectures and serverless. When we talk about serverless, the most common thing that comes into mind is we have a lot of services. We have a lot of different microservices as well, and all of these have to talk to each other. And the key component about event-driven architectures is getting all of them together like a Lego, right? And when you want to think of it as a Lego, all of these individual components should fit in at the right place when you're building it out at the right time as well. And when you want to fix it, it has to be at the right place. So integrating different microservices and different other AWS services in a traditional serverless architecture means that you have to integrate a lot of these different AWS services. And to do them, you have to go through a lot of hassles. And of course, different kinds of workloads need different kinds of integrations. And to do all of it, you have to have something that acts as a glue that can help you talk between different services and also share different events across services. So today we'll be talking first about event-driven architectures, where the focus is about whenever there's an event. So what is an event, right? We talk about events as any change in the system that can occur. So say, for example, there is an event from S3, there's an event from your DynamoDB or anything such, any event that can cause a change, and that triggers the underlying microservices to execute and take on the event, consume it, and work on top of it. So event-driven architectures is crucial when you talk about serverless, because most of things relies on events, and you have to work around orchestrating the whole event-driven architectures. And to do that, we have EventBridge and a whole lot of things with the EventBridge service itself. And today we'll be focused on data streams. So we are also looking into DynamoDB Streams. So any of you who don't know about DynamoDB Streams is basically, it enables a stream of data whenever there is change in, or whenever you write something into DynamoDB. So events such as insert or update or delete, whenever these operations are done on top of DynamoDB table, streams share all of these data, and these can be consumed traditionally with Lambda functions, but now we also have a different way to consume these events. So why is DynamoDB Streams important in serverless architectures? Because most of the times you're using DynamoDB as one of your database choices. These contain data, and you may have to react to data. So say, for example, you're getting some new data into your DynamoDB table, and if you're building a near real-time systems, you have to react to whatever the data changes that are happening on your database. And DynamoDB Streams enables that. With the DynamoDB Streams, you could also make use of event-driven architectures where all these are shared as events, and this invokes execution of other services like Lambda functions, or be it different things with EventBridge Pipes. So basically anything that you write on top of your DynamoDB table, all of these events or changes is being sent into DynamoDB Streams. With it, you can also include a lot of other AWS services. So EventBridge Pipes was launched in 2022, a free event where the Pipes service focuses on bringing integration between two different AWS services and enables point-to-point integrations. So say, for example, you have events from your DynamoDB that has to be sent to step functions. One way how you do it without pipes is you need a Lambda function. You have to, Lambda function would start polling for events on DynamoDB Streams. And whenever there's data change, it picks it up. You would have to consume it, then invoke state machine execution, all of that. So all of that glue code is not needed, especially when you're building with EventBridge Pipes. And when you're using EventBridge Pipes, it also comes with a lot of features. So say, for example, when you want to do a lot of filtering, most of the times when you're consuming all of these data from DynamoDB Streams, you may not want to react to all of the events, right? Maybe your use case is such a way where you want to react only if there is an insert done into DynamoDB table, or only if it's a modification of an existing item, or if it's a deletion of an existing item. Not just these, but also on the data level. You can have more filter patterns written on EventBridge Pipes, which can help you with narrowing down the right events that you want to focus and work with, and also enabling an optional way to enrich these events. So whenever you have these events filtered out, or without even filters, you get all of these events and you want to add more to these events and then send it to a target. You could do it with EventBridge Pipes, which enables you to create more context for the target service to get all of the information about the event and work with it. So what happens with EventBridge Pipes is basically you enable a lot of these things with respect to filtering and enriching, making the event payload itself very good for the target to consume and has all the right context from the event payload itself. So one such way is EventBridge Pipes. And one use case that you often think about is an e-commerce application in an event-driven setup is that you have an event e-commerce application set up, and that application it does tons of things, where one of it is writing, whenever there's a new order that's being created, it writes a new order item into DynamoDB. And from DynamoDB, you get that you have also enabled DynamoDB Streams. So whenever there's a new item, these streams will invoke EventBridge Pipes, where from Pipes, you can filter on with the changes that's there in your DynamoDB Streams, filter to finding the new orders alone, so that you want to focus only on the new orders created, not on existing orders, not on modified orders or deleted orders. So whenever there's a new order, you can filter it out and you can add more details. Maybe, for instance, order has details only about what's on the cart, doesn't have context about the customer, or what's the shipment details, or what's the payment details. All of these things, you could invoke another AWS service, be it step functions or Lambda functions or any of these sorts, which can fetch these data and add them to your event payload. So what really happens is that you're adding more details into your event payload itself, even before it's going to the target. So once all of these things are being done, with enrichment also done, the next thing what happens is it goes into target. So when the data is being sent, or the event payload itself is being sent into EventBridge Pipe target, that again can be multiple AWS services, where you can define, okay, based on use case logic, you want to send into a Lambda function or a step function, you want to orchestrate the whole flow, you could do that with EventBridge Pipe targets, where you send the complete payload, consume it. And since it's not just the data from DynamoDB, only the order created data, but also enriched data with additional information. You don't have to do additional data operations in your target. Instead, the target already comes with more context. This can help you with enhanced processes that can increase a lot of benefits, that can have a lot of benefits for your architectures. So one such way to configure this from the console is that you can go to EventBridge console, search for pipes. You can search that, okay, this is a configured one. So what I'm doing is you can create a source, but the source is DynamoDB Streams. You can see that there's a stream that's being done. You have different other parameters, like what's the batch size in case if there's an error in the pipe execution itself. You can also retry the whole thing. You can define a lot of these parameters on pipes, making it more flexible for you to configure the way how you want the execution to work. And the next off is defining the filters. This is an optional step, but you can go ahead and define the filter pattern so that you can narrow down on those events. Here in this case, I'm trying to search for event names that is only insert. And the next step is enrichment. When you're working with enrichment, you can also specify if the complete payload could be sent into your enrichment state or not. When it does, you have the feasibility to have input transformers where you can transform the input payload itself so that the enrichment state can get the needed information alone, not adding a lot of additional data, making it hard for the state machine to, when you're building state machine, you have to write the right parameters, finding the right path for it. All of it is hard. So what essentially enrichment helps you is also input transformations, where you can just see that what I've done is got my DynamoDB table, new image from my DynamoDB streams, added it to orders. So it's available in one single parameter called as orders, and step functions can consume this parameter alone instead of the other information that DynamoDB stream sends. So from enrichment, one other thing about enrichment is that this works with a synchronous invocation. So what essentially it means is that you would have to use step functions express workflow, where you would have to invoke it, and the express workflow would have to return a response for enrichment to be completed and sending in the data to the target. So what happens next is that it gets the data from target, and the target invocation is fire and forget. It's asynchronous, so you can invoke a step function or another Lambda function or anything such in your target and send all of these data to the target, and target can take the execution ahead. The benefits of this pattern is reduced development efforts, because since this is mostly low-code integration, what it essentially does is it builds that integration between two different services. If you would have to do it in a Lambda function, it's possible, but you would have to write a lot of code for it. You would have to maintain for it. And also when you're writing the middle layers execution has to be taken into consideration. That could add to a cost. And also, since you use different things like filters, it could be cost effective in your workload, which uses tons and tons of data. When using EventBridge Pipes has a concurrency limit of 1,000. So what essentially it could do is it can scale up to thousands of concurrent executions, and it enforces ordering of all of these events. So in case of your use case is prone to use a lot of ordered list, it enables the ordering of these events. Some of the trade-offs of this is you would have to be considerate about the limitations and the payload size that EventBridge has, because what happens is that you can send data to EventBridge, but also you would have to be considerate that enrichment state or the target state. When the data is being sent, it has to be around 6 MB of data, and also on top of it, you would have to be sure that 1,000 is the concurrency limit. But if your use case needs to use millions and millions of data, you would have to work around having different approaches. The other thing is limited monitoring. Since EventBridge can give you metrics about the number of invocations, the errors, all of it, but not details about the errors. So monitoring and debugging these events can be a little tedious and hard for you to identify which was the error, what was the event payload, all of those things. But your enrichment and target, the end services can have observability of its own, and that's where you would have to start with. The dependency with different services across AWS is a lot. And while EventBridge enables decoupling, you're also dependent on AWS services on different integrations. The other point about this pattern is eventual consistency.
Each time it's over.
Thank you.